This object has just been discovered. 3I Atlas was discovered on July 1st by the NASA-funded Atlas survey.
Well, scientists are keeping a close eye on a massive object flying straight toward our sun. The Manhattan-sized object is called 3I Atlas.
The cosmos has sent us another message from the deep. Its name is 3I/Atlas, only the third confirmed interstellar object ever seen passing through our solar system. It's not just a faint dot in the sky. It's a ghost from another star system, a time capsule of alien chemistry now brushing past our sun. And astronomers have just released new, razor-sharp images that peel back the mystery. The discovery came in July 2025, when the Atlas Survey telescope in Chile picked up something moving far too fast for a normal comet. Within hours, orbital data confirmed the unthinkable. This object wasn't orbiting the sun. It was simply passing through, on a one-way ticket from the stars. They named it 3I/Atlas. 3I for the third interstellar object after 1I/ʻOumuamua and 2I/Borisov. At first glance, it looked comet-like, a nucleus wrapped in a thin haze, with maybe the hint of a tail. But the speed, about 60 kilometers per second relative to the sun, was beyond anything a native comet could manage. It wasn't bound to us. It was just visiting, and that made it instantly priceless. As the weeks went on, observatories worldwide turned their gaze toward it. Hubble caught it as a faint streak with a glowing coma, while the James Webb Space Telescope pointed its infrared eyes directly at the object. Those new images are what just dropped, and they've stunned the scientific community. The interstellar intruder, it turns out, is chemically unlike anything we've seen before. Webb's spectrometer picked up a coma rich in carbon dioxide, with barely any water vapor. That's weird. Typical comets from our solar system are mostly water ice, but 3I/Atlas seems made of material far colder, stuff that would have frozen solid in the outskirts of another solar system, maybe in a region similar to our Oort cloud but around a different sun. Its CO2 to H2O ratio was measured at nearly 8:1, one of the most extreme ever seen. In simple terms, this thing was born in a deep freeze, far beyond the warm comfort zone of any star. Polarimetric studies added another layer of strangeness. Light reflected from its dust showed a negative polarization curve. Basically, the way the light waves align after scattering didn't match any pattern seen from our comets. That suggests its dust grains have an unusual composition or structure. Maybe they're covered in more carbon or shaped differently by radiation in deep space. Whatever the cause, it means this object is truly alien in its physical makeup, not just its origin. As more images rolled in, 3I/Atlas started changing shape. Early photos showed an odd anti-tail, a bright streak pointing toward the sun rather than away. That's not magic, it's geometry. The dust was trailing behind it in space, but because of our viewing angle from Earth, it looked reversed. Later, as the object swung closer to the sun, a proper tail formed and lengthened dramatically. The coma brightened, too, flaring with sunlight as its icy surface vaporized. To astronomers, these transformations are gold. Each frame is like a time-lapse of alien physics at work. The way its tail evolves, the rate at which it brightens, even the color of its dust all tell us how material from other star systems reacts to the sun's heat. For planetary scientists, it's like watching chemistry from another galaxy unfold right in front of us. Of course, the alien spaceship crowd has latched onto the news. Social media is buzzing with claims that 3I/Atlas moves too precisely or has artificial symmetry in its coma. Some point to the odd polarization data as evidence of engineered materials. Astronomers have heard this all before. Ever since ʻOumuamua's strange tumbling sparked similar theories back in 2017. But the reality is simpler and more thrilling. Nature is weirder than we think. Every interstellar visitor we've seen so far has defied expectations, but each one has remained well within the bounds of natural physics. That said, it's easy to see why the hype exists. The idea of a rock traveling for millions of years through the void, crossing light years to reach us, sounds almost mythic. It's hard not to wonder what else is out there. Scientists estimate there could be billions of such objects drifting between stars, cast out from their home systems during planetary formation. 3I/Atlas is simply one of the rare few to wander close enough for us to notice. So what exactly do the latest images show? The most detailed composite from Hubble and Webb reveals a soft, greenish halo of gas roughly 60,000 kilometers wide, glowing with scattered sunlight. A fine tail stretches tens of thousands of kilometers away, shaped by the solar wind. Inside that haze lies a tiny nucleus, likely less than a kilometer across. It's rotating slowly, releasing jets of gas that give the coma its textured look, like faint ripples frozen in motion.
And during observation, scientists have been seeing it change color and even grow a cometary tail. Their findings have led to some belief that this object may actually be made by another life form.
Astronomers are analyzing those jets to estimate the object's spin rate and surface structure. One theory suggests the nucleus is coated in a layer of tar-like organic compounds, formed by cosmic rays during its long exile between stars. If that's true, it could resemble the pitch-black surfaces of some Kuiper belt objects, but far older and more chemically primitive. Every molecule we detect helps reconstruct the chemistry of another solar system entirely. But you don't need a space telescope to be part of the story. For the next few weeks, 3I/Atlas is still visible to amateur astronomers. If you're in the northern hemisphere, say in Pakistan, Europe, or the US, you'll find it before dawn, low in the eastern sky. It's faint, around magnitude 10, which means you'll need at least a medium telescope. Aim your scope toward the constellation Leo in early November, or toward Virgo later in the month as it moves outward. Software like Stellarium or Sky Safari can give you real-time coordinates. Start observing about an hour before sunrise. Find a spot with minimal light pollution and a clear horizon. Through the eyepiece, 3I/Atlas won't look spectacular. It's a dim blur, a soft smudge among sharper stars. But if you track it over multiple nights, you'll notice it's moving. Slowly but unmistakably, that blur drifts across the star field. That motion alone is astonishing. You're literally watching a visitor from another star system slide past Earth. If you have a camera mounted to your telescope, take long exposures and stack them. The object's faint tail may reveal itself as a ghostly streak. Some astrophotographers have already captured incredible shots showing its asymmetric glow and evolving shape. Just remember, the closer it gets to the sun's glare, the harder it becomes to see. By early December, it will start fading as it recedes into the distance. The current timeline puts its perihelion, closest approach to the sun, at October 29, 2025. Its nearest pass by Earth will come around mid-December, though still millions of kilometers away. After that, it will vanish forever into interstellar space, never to return. We have just weeks to observe, analyze, and understand it before it disappears. For astronomers, that's both thrilling and heartbreaking. They've mounted a global campaign to collect as much data as possible while it's still in range. Every telescope, from mountaintop observatories to amateur backyard rigs, adds a piece to the puzzle. Spectroscopy tells us what it's made of. Polarimetry reveals how its dust scatters light. Photometry tracks how it brightens and fades. Together, these form a portrait of a traveler from beyond our sun's domain. Why does it matter? Because each interstellar object teaches us about the birthplaces of other worlds. When stars form, they're surrounded by swirling disks of gas, dust, and ice, the raw material for planets. Some fragments get flung out by gravitational encounters with giant planets, tossed into interstellar space. Those fragments carry the chemical fingerprints of their home systems. When one drifts through our solar system, we get a free sample of alien geology. 3I/Atlas is literally cosmic mail from another star. Already, scientists are comparing its data with that of 2I/Borisov, the comet discovered in 2019. Borisov was rich in cyanide and water ice, resembling a slightly more pristine version of our own comets. 3I/Atlas, by contrast, is richer in carbon dioxide and darker in color. That contrast implies that planetary systems can produce very different kinds of icy bodies depending on their star type and formation environment. Some may form closer to their stars, others in frigid outer zones. These details feed directly into our understanding of how planets, and potentially life, emerge throughout the galaxy. There's also a philosophical weight to it. Every interstellar visitor reminds us that the universe is not static. Material is constantly being exchanged between systems. Dust from distant stars could one day seed new worlds. just as our comets may one day drift into someone else's sky. When you look at 3I/Atlas, you're seeing a traveler that's been moving for millions of years, carrying whispers of another sun's story. And while the alien probe headlines grab clicks, the true story is far grander. This object doesn't need to be artificial to be awe-inspiring. It's a survivor of cosmic violence, a messenger from an unknown system that may no longer even exist. The light bouncing off it tonight began its journey across the void long before humans invented writing. The fact that we can now capture that light, analyze it, and understand its chemistry is a triumph of our species' curiosity.